Hey guys. Okay, so this is for homework for week number 4. And so this first IXL topic is HAA. So that's the first one I'm going to talk about, which is factoring by grouping. So basically, it's kind of an extension of what we were doing last week with factoring out the greatest common factor. The reason it's called factoring by grouping, so the idea of factoring is that we're trying to break it down into a multiplication problem by dividing. And so I want to factor by grouping. I'm going to take this 4-term polynomial and I'm going to turn it into 2 binomials that are being multiplied together. So I want to get two pieces. So I'm going to look at it as though this was one group. That's why it's called factoring by grouping, is because you're grouping them together into 2 different groups. So I'm going to come over here and rewrite just so you can see it written out. So I have 10f to the third minus 10f squared. And what I want to do is find the greatest common factor. So the greatest common factor for these 2 terms, if I look at them separately, obviously I have a 10 in both, and I also have an f squared in both. So I'm going to factor out 10f squared, and then I'm going to put what's left behind in the parentheses after I divide out 10f squared, which is going to leave behind 1f in this group. And then it takes out all of 10f squared here, right? I took all of 10f squared out to the front, so that leaves 1 behind. So that is the red piece here. Now I'm going to do the exact same thing with just the blue piece. So it's almost like I'm just doing 2 different problems. So 9f minus 9. So my greatest common factor here is 9, right? So I don't have an f in both groups. So I'm going to take 9 out to the front of the parentheses, and that's going to leave behind f in the first group. And then I took the whole 9 out, so that's 1 behind. So hopefully, if you're paying attention, you notice that this and this are the same. So the idea is that that's where our binomials come from. So the first binomial is the one I just highlighted. It doesn't actually matter which order you write them in. So f minus 1 is that same one that's there. And then these 2 pieces make up the other binomial. So this is a positive 10f squared and a positive 9. So just to point out, if I were to go through here and do FOIL or do the distributive property or go through and do the box method where you multiply them together, you should get back to this answer. So if I were to go through and do this times that, and then this times that, it would turn into this, which we can do together now. Let's go back lines one at a time. So f times 10f squared is 10f to the third. And then f times 9 is 9f. Negative 1 times 10f squared is negative 10f squared. And negative 1 times 9 is negative 9. And so if you really compare the pieces, even though these 2 pieces here in the middle are in a different order, they're all the same actually, right? All the signs are the same, all the numbers are the same. So you're just going backwards from this to this, right? To check your answer if you want to. All right, let's put my answer into IXL. So I have f minus 1 and 10f squared plus 9. Yeah. All right. Let's do okay, so for the next problem, it's the exact same setup, right? I have the same 4 kinds of terms, and I'm turning it into the same thing. This time, I'm going to arrange it a little bit differently, just so you don't feel like you have to write it out as much. So I'm going to rewrite it in different colors like this, so you can see which parts are part of which group.
So I'm going to take the first two terms and I'm going to factor out the greatest common factor, which if I just come up here and say, greatest common factor, which I can do this part even in my head, I don't have to write it down. I have a 9 in both groups, and I also have p squared, right? So I have two p's in each group that I could take out. So I'm going to do 9p squared, which is going to leave behind 2p if I divide it out. And then if I take 9p squared out of this, it's going to just leave behind 1. So hopefully you feel comfortable with the idea that if you're using the exact same term, it reduces down to 1, kind of like a fraction, right? If you do reduce a fraction by itself, then you leave behind a 1. So it's that same idea. This is actually a lot like reducing a fraction. All right, so then I'm going to come over here to the second group and do the same thing. So I'll give you a hint, and it's a big hint. When you have a negative sign here, then that means your greatest common factor needs to be negative. Because if you don't take out a negative, it's going to mess up the matching part. It's going to make it opposite. So I know I'm going to take out negative, and if I look at what I have looks like 7. So I'm going to do negative 7. All right, and that's going to leave behind a positive 2p. And then this positive 7 here, if I divide out a negative 7, it's going to leave behind a negative 1. Because, right, I want the negative 7 times negative 1 to equal positive 7 if I were to go backwards. All right, so my matching piece, 2p minus 1 and 2p minus 1. So that's one of the terms. And then 9p squared and minus 7 is the other. So that's my answer. 2p minus 1 times 9p squared minus 7. I'm going to type that in. I like that it's a square button and I don't have to put in the whole exponent. All right, good work. Okay, so for this one, I'm going to look at 10s to the third minus 10s squared as one group. And I'm going to look at positive 7s minus 7 as my second group. So for this, I definitely have 10 that I can take out of both, and s squared, it looks like. So this is going to leave behind 1s, just 1s, right? And then I take out all of that, so it leaves behind a 1. Again, another time where IXL just keeps repeating the same type of setup, which I wish they would vary that a little. Here I have positive 7. So this time I have a positive here in front of my second group. So I don't have to worry about making this negative. So it's going to be positive 7, and that's going to leave behind s minus 1. And then once I rearrange all this, it looks like my answer, I'm going to have this s minus 1, right, as one group. And then this 10s squared plus 7 as my second. So hopefully, if you're thinking ahead, you're saying to yourself, what would happen if this and this don't match? Well, then, my friend, I will tell you that you did it wrong. Something is wrong. Because it will, as long as the assignment is set up to be factor by grouping, then it's going to factor this way. It will match. That's one kind of way in the middle you can check to make sure you're on the right track. All right, let's type in answers. And then I think I'm going to skip forward and see if there's another level that's a little more challenging. S minus 1. And S squared. That's heavy. All right, so right now it looks like I'm up to level 28. So at 43, looks like mostly what's going to happen is they're going to start making bigger numbers. So you can go through and do this one. Sure, why not? So I just have to be more careful
It's kind of like just bigger fractions that I'm trying to reduce, right? So I have 46q to the third minus 23q squared. So if I go through and put these into groups, I can take out 23 and then q squared, which is going to leave behind 2q minus 1. And then if I do the same thing with that, positive 36q minus 18, I can take out a positive 18, which is going to leave behind a 2q minus 1. The answer is 2q minus 1, and then 23q squared plus 18. Just to point out, these don't actually have to be in this order. You could switch them around, and IXL is not going to care. You can do it either way because it's a multiplication problem. All right, let's move on to the next topic. Okay, so the next topic is factoring quadratics when they have a leading coefficient of 1. And so I told you that we were eventually going to do something where it has a leading coefficient that's not 1. So let's grab a screenshot. All right, so this is IXL topic S9P. And like, here's the title there, like I said. And so that coefficient of 1 means that there's an invisible 1 here out front. Eventually, we're going to do some that have other numbers besides 1, you know, and that will definitely make it a little more complicated, but it's very doable still. Basically, what you're trying to do is you're trying to take a trinomial in this case. So the last one was we're taking 4 terms and turning it into 2 binomials. This time we're taking 3 terms or a trinomial and turning it again into 2 binomials. So it's going to be the same type of answer as the last one. I'm going to have a parentheses and a parentheses at the end. These are a little bit more, it's not as much of a process. It's a different process, I guess. The issue is that if you think about doing FOIL, right, that idea of having 2 binomials, you're going to multiply this times this, and this times this, and then this times this, and this times this, just like we always would do. And some of those are easier to see than others. So I'm going to go back and say, if you think about multiplying the first 2 together, that gives you this number. And when you think about multiplying the last 2 together, it gives you this number. The real issue is how you get this number, because this number comes from multiplying 2 things together. Let's see. Oh, that was wrong. Sorry. So I didn't do this one, and I didn't do this one. So these 2 purple lines is where this comes from. And this is where I would normally have to combine like terms, right? There's that middle term is from combining like terms. So in this situation, for example, if I'm looking at 20F, how did 20F happen? Did I do 19F plus F? Did I do 10F plus 10F? Did I do negative 2F plus 22F? So hopefully you're getting the idea that there's a whole bunch of different ways that 20F could happen. There's a bunch of different combinations, basically. So that's kind of the trick with these, is trying to figure out which combination is what created that 20F. But the good news is it's also related to this number here, because it has to multiply to make this number at the end, remember, because it's this green part, right? I have to take the last part here and the last part here, multiply them to get this. So let's erase some of this stuff and start over. So basically what I'm saying is if I'm turning this into a binomial, I'm going to multiply this number times this number to get this. And then I'm also going to multiply this number times this number to get this. but it's that part in the middle that I have to figure out. So the trick here is to figure out two numbers that multiply to make 19, but then are going to add up to make 20. So you're looking for two numbers that multiply to be 19 and add to be 20. Just to write it down in case you're a visual person that kind of likes to see the words and not just hear somebody say them. I usually call this the product and the sum. So when I start a problem like this, I'll say, what's the product and what's the sum? So over here, I say, okay, the product is the 19 and the sum is a positive 20. So two numbers that multiply to be 19 and add to be 20. And I feel like a lot of my honors algebra level students like this because it kind of feels like a game to figure it out. This one's a pretty easy example because 19 is a prime number. So if I'm trying to find two numbers that multiply to be 19, there's only one option, right? It's 1 and 19. And then f squared is easy. That's f and f. So do you see how it's pretty easy to figure it out once you know what those two numbers are? So the two numbers that make 19 and 20 are 1 and 19. If I multiply these, I get 19. If I add them, I get 20. So that means my answer here is f plus 1 times f plus 19. F plus 1, f plus 19. All right, so for this one, maybe I'll stop screenshotting since I'm not writing so much down. Annotate this tool set. All right, so for this one, basically my product is 11, right? So really the product comes from multiplying the first number times the last number. So the product comes from multiplying these two. And then the sum comes from what the middle term is. It's always a 1 right now, but someday this will change. I'll have to multiply by 2 times 11 or 3 times 11 or something. But for now, it's just 1 times 11. So the product's 11 and the sum is 12. So two numbers that multiply to be 11 and add to be 12, which again, just like the last time, since these are prime, you can just, the only combination is 1 and 11. So 1 times 11 is 11, 1 plus 11 is 12. So that means my answer. So these are the two numbers I'm going to fill in basically. So I have W and W, and then the two numbers I fill in are a positive 1 and a positive 11. Okay. So for this one, my product is 1 times 23, so 23, and my sum is 24. So just like last time, two numbers that multiply to be 23 and add to be 24 because it's prime. So I'm going to get h plus 1 and h plus 23. So this number fills in this number fills in that. And then it's h because it's h squared. Okay, let's jump forward because this feels pretty easy so far. This one's also pretty easy. Let's see if I can get a different kind of example. Here we go. This is better. All right, so this one has a product, so 24, and then a sum of 14. So this time I'm looking for two numbers that multiply to be 24 and add to be 14. So we should go through and probably figure out products, right? So I gave pause just so you can kind of think about that for a sec. There are going to be times where it's going to be hard to figure out. So usually I tell students, come over here to the side and make a list of two numbers that multiply to be 24. So you have 1 and 24, you have 2 and 12, 3 and 8, 4 and 6, and then 5 doesn't work. And then once I get down to 6, I'm going back up through this list again. And then hopefully, if you're trying to think of which two of these would add to be 14, oh, sorry, I didn't mean to draw. It's going to be the one, obviously, here, where I can combine 2 and 12 to add up to 14. So this is my magic pair or whatever. So I would go through and say, here are my two binomials. I have t as my variable, and so my two numbers are a positive 2 and a positive 12. Okay, let's see if we can get some more examples in here. Oh, look, I'm to the challenge zone. Okay, let's do this one. So my product for this one is 40, right? So 1 times 40 is 40. And my sum is 22. So two numbers that multiply to be 40 and add to be 22. So I'm going to come over here and think about what numbers will make 40. 1 and 40, 2 and 20. So already I can tell this is it, right? So I'm going to have t plus 2 and t plus 20. Yeah, I would say overall these are not overly challenging. So I think this will be pretty easy practice for just figuring out the pairs. So I'm just trying to jump around a little and see if I can get, oh, good, here's a negative finally. Let's do this. All right, so for this one, my product is 24. And my sum this time finally has a negative sign, which is kind of what I was hoping it would give you. So you're looking for two numbers that multiply to be a positive 24, but that negative sign does matter. You need two numbers that add to be a negative 10. So I'm still going to come over here and think about the pairs I have that make 24. So 124, 2, 12, 3, 8, and 4 and 6, which we just did all this, right? Hopefully you can see if you compare these that there is a way to combine 2 and 12 to get 10, right? You could do some kind of subtraction-y thing if you combine it with a negative sign. But I also want to point out for this one that you could also have some kind of pairing of 10 with 4 and 6. So this is one of those ones where sometimes it's hard to figure out which way it is. If you look here, I could do negative 12 plus 2 to equal negative 10. But the problem is if I use a negative 12 and a positive 2, it's not going to multiply to be positive anymore, right? Because when I multiply negative 12 times positive 2, I'm going to get a negative 24 here. So negative 12 and positive 2 don't work. They add to be negative 10, but they don't multiply to be negative 24. 4 and 6, though, I could do a negative 4 plus a negative 6. That would make negative 10. And negative 4 and negative 6 do multiply to be a positive because it's negative times negative. So this is the right pair. So this is actually a really good example. I'm very glad this came up. So I would have Z and Z as my groups. And then this time it's going to be a negative 4 in here and a negative 6. Okay. Awesome. I feel like you're pretty prepared to try this on your own. But please come in and get help during asynchronous time if you feel like you need more help in this. All right. Good luck.